In this video, I'm going to attempt to help you understand how to program your Arduino or Teensy, if that's what you've chosen, to use the collective that we've built. So where we start is this website, which I'll put in the links below, which is also off Hobby Tech Gear if you've watched his videos. So this is hopefully just a simplification for this purpose. So once you've got that open, what we'll do firstly is open this document here, this Pro Micro Firmware Instruction PDF, and that link on the left. If you haven't set translate, it's that link on the left. If we open that, and that opens this document. So the key to understanding how to get this to work is this point here where we're going to join onto the reset pin and the ground pin of the Arduino. So the way the gentleman's done it here is he's plugged the Arduino into a breadboard, but I use the Arduino without any pins in it, so I don't really want to solder all these into it. So what I do is where these two wires are connected here, I solder two wires on there just with a little button on the end, a tactile button on the end, so I can hit the reset. So just two wires from ground and reset to a little button. Then, as it says in this document, power it up and short those two wires together twice in the first 8 seconds of its powering up. This will trigger the Arduino to show what port it's on. So you notice here he says the Arduino bootloader is now active and ready for the firmware upload. This here, where it's showing the ports, is essential for you to find because it will disappear. So you need to know it's port 22. Once you know it's port 22, then as you read through this document, you'll find that you can configure the firmware, which we're going to open in a moment, for port 22. All right. So we'll do that now. We'll open the firmware. Oh, by the way, firmware download is this last one here, MMJoy 20161101. So if you download that one and open it in a folder, it doesn't actually install, but it runs from the folder and you'll have to enable it. So I'll open the firmware. I've got that already in a particular place in here. It's that one. And we open MMJoy setup. Enable that. And there we have it. So if we've just plugged the Arduino on, then it would have come up showing something of this nature. So we're on the firmware tab here, and you would set your COM port there with the COM port that you recorded earlier. So in that instance, in that video, it was 22. You would set it as 22 there, or depending on what you found from the setup. And enable auto start. Select this file as in the directions and the chip as in the directions, bootloader and so on. So follow that document and then turn this on. Once you've got this set with the correct COM port set, then if you press the reset button, it will then come up with the window that he showed down here a little. It'll come up with this window and it will load the firmware onto the device. Very, very simple, very easy. Just follow this document through and you'll understand it. So this is a slightly different version of MMJoy, 2015 version, and his one doesn't have that switch down there to set this to automatically load, as in the version that we've got here. So this auto start function is very handy because you can just set the COM port there, trigger a reset, and it will load it. So once it's rebooted, The Arduino will go through a reboot. Once it's rebooted, it'll come up like this line here. If we click on that, so I've got a device on here now that is unprogrammed. So I've gone through those steps. It's unprogrammed, and that's the device that I've got there now. Just get rid of this one because we don't need that one anymore. We don't need that one anymore. So we've got this one here. That's the device. So just check that your device comes up correctly. At this point, we can start to do a few things to set it up. So let's go to joysticks and axes. And the first thing we do is press clear sets and then save sets to device. And it'll run through that step. It'll restart and it comes up there as a cleared device. Now the benefit of doing that is you make sure that there's nothing unknown in the device, that there's nothing left over from any other operations. So firstly, what we want to do is to set some identifiers. So here we might set, doesn't really matter too much. I usually just use the last two figures. So we might put in there B6 and B6. And then the last one, I usually do the same thing. B6, 6. And in this case, I'm going to call it, I'm going to change the name, MMJ I'm happy with. I'll call it just dash collective. Collective. Now, the benefit of doing this is that you can create more than one device. You might have other things that you create later. And by changing particularly this vid number here, you can have them report as different devices. Using Arduino on its own with its own coding system and its own IDE is very, very difficult to do this and very hard to manage. So this way you can have different devices in here and you can have them with different names and they will show on the system. So we've got that part done. First thing we want to do, with our collective, we've got 3 different controls. So firstly, we want to set that the control is coming from the internal sensor, which is the internal ADC, and the port that it's coming from. So in this case, it was, let me just open the diagram. So in this case, our collective itself is connected from the output of the Hall device into this port here, which on the Arduino in this scheme is called B4. So we go back here and we select this to be from this list B4. And we want it to report no, that's fine. The next one we want is another internal sensor, and it is the throttle, which is B5. Go back there, set this to B5. B5. The next one we want is an internal again, and this one is going to come on B6. Go back there, going to come on B6. There's a lot more to go, but we'll upload that to the device and see what happens. All right, so then we go save sets to device. So this is going to write this configuration that we put in here, and it's going to write this configuration into the device. So save sets to device. No assignment. MCU port channel. Oh, assignment here. So we're going to set these two. This is internal sensor. So we're going to set the first one to be slider. The next one we're going to set to RX. The next one to RY. Now we'll save sets to device. It'll reboot. And now when we find it in the list, you notice now it's called MMJ Collective. It has the identifiers that we gave it, which sets it apart from any other USB device on your system. And it's loaded up again with all our settings. So we've told it what we want here, but this isn't really configured yet. So if we go to Calibrate Helper and we select Access Name, it'll turn them all on. We can go Clear Data, make it all fresh, and put each of our controls through their paces. So firstly, pull the collective up and down, up and down. And you can notice that it's set, so there's a minimum it's finding of 195 and a maximum of 855. This is interesting because it shows you that it's not giving you full travel from 0 to 1024, and that's not a problem. This is to do with the Hall effect device that I'm using. It's not giving me quite the full travel, but it's going to scale correctly, so that's not a problem. The next one, I'm going to rotate the throttle, and you'll see it'll change from 0 to 419, and it doesn't go full scale either, but that's going to be fine because it will scale. The last one is the knob, and you'll notice it'll scale right up to 1024 or 1023. 0 to 1023. And then we save that calibration and then close that window. So now you'll notice that transported over to this part of it is that calibration information. The way we want to set these, now that we've got that, is we want to set them to saved without center. Saved without center and saved without center. And now we can save that to the device. So save sets to device. And it will reboot. So there we go, we've got it again. So let's have a look and see whether we had any effect on anything. So let's call up the joystick tester. Which opens like that. So we've got these three different devices. If I move the I've got the wrong one selected there. Collective. If I move the collective itself, notice it's moving there. It's going from 0 to full scale because the system itself has scaled the figures that we gave it to compensate. So we get full scale travel there. Let's turn the potentiometer. You notice it's moving up and down as well. We're getting full scale travel on that one, and then the throttle on the stick, remove that one, not getting anything. It's showing here. No, it is showing. It's this brown line. I don't know what I'm doing. Okay, so it is scaling. Okay, so that's happy. So we've achieved that. We've got our linear inputs all configured correctly. And the next thing to do is to set up some buttons. So let's click on the Buttons tab. Now in my instance, I used the Shift register. So that's this drawing here. These two devices configured just exactly as it's drawn here. And I've put some figures in here for the way this drawing works. So let's bring that across a little so we can see that. So you notice here it tells me to select the 74HC165, which we do. 74HC165. We've got two of them. And on here, CS is connected to D0. So we do that. CS connected to D0. And data is connected to D1. Connected to D1. All right. So mine's configured exactly as this drawing is. And this is the data that will make it work. So there's an essential feature that's not mentioned in any of the documentation that I could find. And one is that there's a clock that appears here on B1, and it's mentioned here, SPI-serial clock, that needs to be connected up to clock here. And it will become active once you've told it that this is the sort of configuration. So again, we go Save Sets to Device. It will reboot. And we're back again. Click on it. Becomes active. Now, if everything's worked correctly, when I hit any of the switches, they should light up. Oh, look at that. So that's my first left, second left, top. So the order of these is rather immaterial. It doesn't mean very much at all. Just the fact that they work is a real achievement. So they're actually the hat switch buttons that I'm pressing now. Bring that on center a little. So let's set up the hat switch. If we click here and till it's like that, double click, and then hit the wrong one. Double click again. The top button is my hat switch, top or up, right, down, left. So they're activating when I touch the switch, it's assigning it. So these are our Windows buttons. These are what appear in the Windows system itself, the virtual buttons. And we can assign any of our physical buttons to any virtual button. So if we want the buttons across our collective, so for instance, we're working from top left to top right, well then we would go double click, top left, push up. Next button might be the down switch on that one, push down. Next one, push button, and so on. So I'm working across the top of the collective. So what it should have been. So I'm doing all the switches and assigning them where I want them to be. Okay, so that's all the switches assigned. So we've done the 74HC165 was working. We've shown that because we're getting our switch buttons here. We've assigned them to virtual buttons in Windows. And you can assign them, as I said, to anything that you want in there. So then we can save sets to the device. That will reboot. Just click on it to activate it here. So we just prove our buttons are working. Yes, they're working. and so on. Now let's check it. Okay, button tester. Select the right device, the collective, and now if I press top left rather, next one, you notice they're coming up in the order of what you've configured. And our hat switch now. So isn't that really cool? You can close that now. Now let's have a look at Windows' own configuration tool. That's this one. So we've got our collective, and open that one, and look at that. So that's the throttle, that's the potentiometer, and the slider. Now interestingly, the slider is up when I've got my collective down, and down when I've got my collective up. Well, you can rotate it in Microsoft Flight Sim or other programs, but why not have it going in the direction that you want in the first place? So let's fix that. We'll come back to this tool in a minute. So let's fix that. That's the slider. We can go away from there. So we can go back here to axes, and slider was on before, and notice along here we can say inversion. So we can do that. Save sets the device. Activate it again. Open Windows Joysticks again. Open our collective. Notice the slider's down now. Pull the stick up. Look at that. Isn't that a nice feature? Inversion is so easy. So we've proved that all of those things worked. There, what about our buttons? Button 1, button 2, 3, 4, 5, 6, and so on. That switch, that all works correctly. All right. So what if you want to do something a little more? Well, I've done something a little more. I actually put another push button onto these two pins here, D3 and D2. That's pin 1 and 2. There was a reason for it, but just to demonstrate it, I'll show you what happens. So if you activate those two here by selecting D2, D2, and then D3, this will activate this button matrix that you can have as well. It doesn't have to be just this, you can activate these as well. And there's instructions in the documentation on using button matrix, but for this case, I only wanted one button, and that was this one here. So all of these are going to move along. If I go save sets the device now, and this button is now active. So that's another little push button that I've got on the side, but that's entirely up to you. Of course, you'd want to have that in place first before you started setting your buttons over here, because all of this numbering gets pushed along by one. So I'll take them out again, just for demonstration purposes. So when you set up initially, if you had that extra button or any extra buttons using the matrix system, then you would want to have them all there first before you set the SIP register, the shift register rather, in place. So I'll save that back again. That'll reload. And we should have that back again. And my little button doesn't work now, but my other buttons are all working. Windows joysticks again to demonstrate that functionality. That's all working. That's working. Throttle's working. Now there is one other function that I will show you before we stop this. You may have a situation where you want a button to stay down on a press and come up on a press. So press on, press off. Say for instance this button here, let's work it out. So this one here. So if you want that to be a press on, press off button, you'd click on here and change its state to be soft switch. And let's save that to the device. And I'll demonstrate to you what that actually means. Okay, so we're reloaded. So that was button 4 here. If I press it, you notice it shows up here. And you say, well, so what? But now let's open it in Windows Controls. And look, it's on at the moment. So it's translating to button 6. Press and release, press and release, press and release, press and release. Isn't that a handy function? Sometimes you want something that will stay on until you turn it off. That's just an interesting feature that can be helpful. So I hope that helps you understand a little bit about how to use the Joy suite for programming the Arduino. There's no limit to the devices that you can have, because using this configuration up here, you can change the identifier of all the devices you have on your system. And there's really a massive amount of switches you can have. It's up to you. You can use rotary encoders, which I'm not going to go into, and other functions of this. It is a very, very sweet system. So I hope that helps somebody.